When we think about astrophysicists' studies, our minds naturally tend to imagine distant stars, but in reality, we cannot study them up close. Stars are celestial bodies so far away that we have no practical way to reach and observe them up close, at least not within our lifetimes or through immediately feasible space missions. The distances are so vast that even sending a probe to them is an unachievable feat for us, at least within the lifespan of one or more generations. However, what we know about stars comes from indirect observations. Telescopes are our primary tools of study, but there's also an aspect we often take for granted. We are actually much closer to a star than we might think. Our sun, in fact, is a star, and we could consider it as an example that is directly accessible to us. If we think of the sun as a star to study, the perspective changes significantly. Not only is the sun close to us in astronomical terms, but it is also theoretically reachable with a space probe. Nevertheless, sending a probe to the sun is a far more complex endeavor than it might initially seem. It's not just the challenges of intense heat and radiation, but also the technological and physical difficulties associated with designing and achieving such an ambitious goal. In fact, there is a space mission currently attempting to do just that, getting closer to the sun than any probe has ever gone before. The probe in question is the Parker Solar Probe, an ambitious NASA project. In December 2024, this mission achieved an incredible record. It approached the sun at a distance never before reached by any other spacecraft, just 6.1 million kilometers. Although 6.1 million kilometers might seem like a vast distance on a human scale, it is astonishingly close in astronomical terms. To give a clearer idea, we can imagine a scale where the distance between the Earth and the sun is reduced to 1 meter. On this scale, the Parker Solar Probe would have come as close as 4 centimeters to the sun. We could almost say it touched the sun, though technically this isn't entirely accurate, but it comes very close, considering the probe has passed through the sun's outer atmosphere, known as the solar corona. To better understand the distance it reached, we can compare it to that of Mercury, the closest planet to the sun. The probe approached to about 1/10 of the distance between Mercury and the sun. Before this record, the Helios 1 and 2 probes had reached distances similar to that of Mercury, but that was 42 years ago. The fact that it took so many years to get this close to the sun is no coincidence. The Parker Solar Probe mission required decades of development, starting from the first ideas in 1958, to overcome enormous technological challenges. But why is studying the sun so important? Because our star is not just any star, it is fundamental to our very existence. Every biological process on Earth depends on the energy we receive from the sun. Furthermore, the sun has a direct impact on our climate and many other terrestrial phenomena. And it's not just about studying the sun for scientific curiosity. The behavior of the sun is unpredictable, and we do not yet fully understand how its solar cycle works. We still don't fully grasp the workings of the solar wind, the flow of charged particles that the sun constantly emits toward Earth and beyond. Additionally, the sun can produce violent energy eruptions that are, unfortunately, difficult to predict. These solar phenomena can have devastating effects on Earth, damaging electronic equipment, interfering with satellite systems, and posing a threat to astronauts, especially those undertaking long-term space missions. This is why it is crucial to study the sun up close, to better understand it and perhaps predict its most violent episodes to protect ourselves from potential harm. Studying the sun up close, however, is no easy task, and the Parker Solar Probe was designed specifically to tackle and overcome the challenges of a mission to the sun. The first difficulty that comes to mind is, of course, the heat. The temperature of the solar corona, the outer part of the sun's atmosphere, can reach millions of degrees Celsius. Despite this, the density of particles in that region is very low, meaning that while the kinetic temperature of the particles is incredibly high, the heat transfer is not as intense. In other words, although the particles are very fast and very hot, they are not numerous enough to cause extremely high heating of objects in the area. However, the Parker Solar Probe still has to deal with temperatures nearing 1,400 degrees, which would be enough to melt any traditional instrument. To protect itself from this heat, the probe is equipped with a special heat shield, similar to those seen in science fiction movies like Sunshine, made of carbon and over 11 centimeters thick. This shield reflects most of the sun's energy, and allows the probe's instruments to remain at a manageable temperature of about 30 degrees Celsius. Beyond the heat, another major challenge is the probe's trajectory. Once an object is in orbit around the sun, it is traveling at a very high speed, about 30 kilometers per second, roughly 108,000 kilometers per second. This speed is necessary to avoid the object falling into the sun. If we want a probe to approach the sun, we need to reduce this speed. Otherwise, the probe will never manage to stop. This deceleration process cannot simply be achieved by burning fuel, as might be done for other space missions directed toward planets. Instead, the Parker Solar Probe used a maneuver called gravity assist, leveraging Venus's gravity to alter its trajectory. This approach allowed it to gradually slow down and get closer to the sun, following an elliptical orbit that brings it progressively nearer. Subsequently, as the probe approaches the sun, it is accelerated by the sun's gravity, reaching incredible speeds. At its closest distance, the probe can reach a speed of about 700,000 kilometers, making it the fastest object ever created by humans. In practical terms, it could circle the Earth in just 3.5 minutes. But it's not just heat and speed that pose challenges. There are also solar radiation, which is hazardous to instruments, and the solar wind, composed of charged particles that can damage electronic devices. Moreover, the distance from the sun results in signal delays. Commands sent from Earth take about 8 minutes to reach the probe, meaning it must operate autonomously. The Parker Solar Probe has faced all these challenges and succeeded. Since its launch in 2018, it has achieved significant milestones. It became the first probe to cross the solar corona, measured the sun's magnetic field, and collected unique data on the solar wind. In the future, the mission will continue gathering data to help us better understand the sun's behavior, predict solar storms, and improve the protection of our infrastructure. Additionally, the discoveries made by the Parker Solar Probe could have significant implications for progress in nuclear fusion and our understanding of plasma physics. Thank you for watching. Leave a like, subscribe to the channel, and activate the notification bell so you don't miss the next videos.